The equation F net, meaning net force, equal F friction, force of friction, minus CV, where V is regarded as the velocity of an object and C a constant that allows us to determine how much drag force the object experiences when moving at velocity V. This equation can be written as mx double prime equals force of friction minus CV, and then as x double prime equals force of friction over m minus c over m times v. This equation can then be written as, well, this right hand side can be written as F friction over m minus c over m times x prime, since velocity is the derivative with respect to time of our position function. That puts this equation into form x double prime equals f of t x x prime. That is, x double prime is a function of x prime, and in this case we don't explicitly have t or x in the expression, but nevertheless we don't have to have t and x explicitly indicated in the function. So x prime equals f of t x x prime is one form of this function, and it's a general form. Now we'll see why we need the x and the x prime to indicate the general form, because if we add negative kx to our net force, we get the equation F net equals force of friction minus CV, and I'm going to call that Cx prime now, and minus Kx. So we see that this is of the form, well, we can write this as mx double prime equals all this, so that x double prime equals force of friction over mass minus c over m x prime minus k over m x. And this is also of the form x double prime equals something, and that function would be a function of our clock time, our position, and the derivative of our position. And in this case we see that the position and the derivative of the position are now part of our function.